Hi, Sandeep. Any issue to start the program? Sandeep?
Sir, give me, sir, give me 5 minutes, 5 more minutes. Because she's
Just to
able
inform to the participants, na? Just 5 minutes, madam will be joined. So all the participants, please, okay, understood, okay? Due to some technical issue, madam is unable to join right now. Within 2 or 3 minutes, she will be available for the class. You have to time inform to the participants. Sandeep.
Sure. Dear participants, just wait for 5 minutes. So due to some technical issue, that speaker is not able to join. So within 5 minutes, she will join and then we will start the session.
Good afternoon, madam. Thank you for joining. Am I audible?
Yes, sir, you are audible. Thank you very much for joining the session, man. Due to some technical issue, we are facing some problem, but there is not at all a big problem. So welcome to Dr. Vandana Bharti. She is currently serving as assistant professor in School of Artificial Intelligence and Data Engineering at the IIT Ropar. Previously, she is also the assistant professor in the Department of Computer Science and Engineering at IIT Harvard. Then she completed his PhD from IIT BHU. With her expertise in artificial intelligence and data engineering, along with her commitment to excellence in teaching and research, Dr. Bharti has made significant contribution to academia also. He dedicates to nurturing innovation and inspiring young mind reflection, her passion for advancing knowledge in emerging technology also. So we are honored to have Dr. Vandana Bharti with us today and look forwarding to benefit from her valuable insight and experience. So welcome to ma'am for joining this session, and you just give us your valuable time, us and as well as the participants.
Yeah, thank you, Pramodji. Is it audible to you?
Yes, you are audible as well as your screen is also visible.
Okay. Thank you, Pramodji, for the nice introductions. And sorry for the few technical glitch that we are suffering before joining. So it took 15 minutes more, right? Anyway, I will try to give you the basic of that, the AISI, that what is the security, because since you know that that the security is the major concern. Okay, now how we are developing AI, so another important major concept is that we need to think about that how we can secure the model, how we can utilize the very large scale of data with a different modality, with a different samples. So one major concept is that the federated learning. So this talk is all about the federated learning. What are the foundation, few classical algorithms, and what are the current direction you can do. Since it's a DB program, definitely I will give you a idea of the basics, understanding of this, what are the available libraries are there, and what is the ongoing research in that, so that you can continue in your area also. Okay. So basically, federated learning is a one kind of a learning paradigm for deep learning. There are different learning. For example, if you have heard about the machine learning paradigm. Similarly, for the deep learning architecture, we have a different kind of paradigm for the learning, and some are the meta learning, few short learning. These are the different paradigms. One of them is a federated learning, which talks about the distributed setting and how to secure the model side, how to maintain the privacy of your data. So basically a question to begin with, that suppose that 10 organizations want to build a better machine learning model. Okay. And each organization has a useful data, but none of them is willing to, technically we don't want to share, or we don't want to send it to a common server. Okay. So in such situation, earlier we don't have a solution. We have the only, if you have heard about even the computer science, we have heard about that we have a one server and different client. Whatever communication is happened between the server and client, we need to send all the repository, all the data resources or the central. If the central server fails, we don't have any options, right? So in current scenario, the most important thing is the data privacy. I have my data. Definitely, I want to use the machine learning or deep learning architecture for analyzing those data, but I'm not willing to share my data. Why people are not willing to share data? Because it's a privacy norms also. It's a confidential, sensitive data. Just like in the, for example, defense industry, if they have the uh, different corporate at the different centers of the defense, if they want to share, they don't want to share the data from the one region to another region. Okay. Similarly, for the hospital also, if we have a multiple hospital, every hospital has their own data. They have the confidentiality, they have the patient data confidentiality. They can't share the data and the patient ID. Okay. Because it is not following the ethical norm if we share the data without taking any consent of such cases. So in such cases, that the usual answer would be that collaborative training, but it is impossible unless the data are first collected in one place. So if I am collecting all data from your different colleges, different industry, and I'm collecting at a one place, at suppose at IIT Ropar. So in that case, I should not be in the malicious aspects. I don't follow the malicious activity because all data is with me. So you should have a trust with me. But generally in the real time scenario, we can't trust because it's a net that we are sharing the data through the link or through the different process. Okay. So why federated learning comes? So because of this scenario, because of this setting and the data privacy, federated learning comes because it changes these assumptions. It asks whether the learning process can travel to the data rather than forcing the data to travel to the learning process. Okay, because I want to analyze my data. Why should I share my data to some other places? Is there any one mechanism or one AI model that can be shared with among that? That is not a problem. Okay, so federated learning basically it comes from that aspects. So what exactly it is? Basically, it enables machine learning engineers and data scientists to work productivity with decentralized data, with privacy. What do you mean by decentralized? It means you don't have a data at a one server or central server. Okay. It means multiple hospitals can own their own data at their own site, but they can share the AI model. Okay, any network, neural network, or any kind of machine learning or any architecture what we are, that can be shared, but data is within that premise of that local host. Okay, so why federated learning? Why it suddenly comes to boom in the federated learning? Because see, data is born at the edge. If you have your smartphone, if you see that these things, if you see that the different automated vehicle, different sensors are there, you have your smartphone, you have a smartwatch, even in the car you have the smart devices. So generally these data is born at the edge. All these are the comes under the edge devices. So if you have a billion of phones and IoT devices constantly generate the data, and data enables better product and smarter model. You know that how to, when we are learning, for example, suppose if I am taking a one math problem, okay, one geometrical problem, only with a one problem, maybe I'm not getting a very good aspects of solving those things. But similar kind of that, if I want to make if I want to be perfectionist in a certain kind of problem, I can try a multiple problem of a different complexity. I will try to solve those things and I will train myself self for such type of problem. Similarly, if you want to make a model smarter, if you want to really improve some product or something, it means you have to learn a data. And data basically how much data you have, it can enable the smarter model, it can enable the smarter performance, it can improve the quality of the product development. But do you think that every site has the same data? A small sensor, if you think a small sensor and the smartphone, do you think that the both are generating the same amount of data? No, they are not generating the same amount of data, but we can take the benefit of the information without sharing the data. Okay. So second reason is that, can data live at the edge? See, that earlier we have the centralized. So the reason behind is that we don't want to share the data from this edge to something else. So can we keep these data alive live at the edge only? So basically data processing is moving on devices. Okay. What it does, it improves latency, works offline, it better battery life, privacy advantage. Because see that if you have the data at this side, you don't have to share every time. If I'm sharing the data from some other central server, so it means you can understand that if I have a GB of data, then again I have to share the upload the GBs of data, some other devices GB, again I got a one few chunks of data, again I will upload offload. So that is not feasible. So to improve the latency in the performance, because why you are using a smartphone nowadays, because few apps, and why you are using a specific app in your mobile or in any devices, the reason is the latency time. If I'm giving if I'm requesting something and it took 2-3 minutes, okay, and some application, if you are using, if giving a response within a few seconds, definitely I will choose with the few seconds which maintains the quality and everything. So if we keep the data at the edge, then we are trying to improve the latency. We can work offline. We don't bother about that what the other person has the data. Okay, I'm only bothering about, okay, my data has this distribution. I have some AI model, and maybe that AI model can learn from a different source of data. Second one is better battery life. If you do everything in our edge device, suppose if I enable the AI or AI model as well as the data on the edge device, you don't have that much battery life. Okay, that is the, if you see that in the drone technology, that is the major drawback, because you have the limited battery life of a particular drone, and if you want to do everything on the drone, so it is very it is very difficult, because see that the because even training a model, even in taking an inference, all these things, it takes a computation time, it takes the energy also. Okay, and that small sensor, a small device doesn't have that much battery life. So to improve the better battery life, this techniques comes in the picture, that we can solve the same problem in a different way. Next one is the privacy advantage. In such cases, since you are not sharing your data, your privacy is maintained. So, solution for this, that we can get the on-device inference for mobile, keyboard, and cameras. Okay. So next one is that what about analytics and what about learning? It's fine that we keep the data in our devices, we maintain we are not doing everything, offloading, uploading every time, so we are enabled to maintain our battery life in the system. So what about the analytics, what about learning, how do they learn? Okay, so basically it's a shift of a paradigm from centralized to decentralized data. Okay, if you see that the standard setting of the data, earlier what we are following, that you have the computation resource, you have the one data center. Data center means, let us assume that a one server which performs all the computation, but you are keeping the data at that place also. Okay, that is the centralized data set processing. So it is a standard setting in machine learning or the deep learning. I'm writing a machine learning because it is a part of the deep architecture, neural network, and all these things. Okay, so it considers a centralized data set processed in a tightly integrated system. Okay, but in the real world, data is often a decentralized, because you are getting a data from the sensors of the car also. You are getting a data from the hospital. You are getting a data from a different your CCTV and other data, different kind of data. So this assumption, earlier we are doing that, but this assumption is not truly suited in the real time scenario. So to work upon the decentralized across many parties, we need to think about some algorithm which can enable the same machine learning algorithm to work in such scenario. So, we can move in that direction. So what is the reason? Why can't we just centralize the data? Okay, we can maintain a very huge data center. We can keep all the data, or we can dump all the data. We can dump all the AI model. We can do that, right? But what do you think? That is it to centralize the data? Is it very easy? You understood nowadays. You have seen that the GPU costs, right? It means if I'm trying to make a one data center for a one applications, okay, and one central server, and I am trying to put all these things. First thing, it is too costly. Okay, in terms of the setting of that data center, and if you see that the energy consumption and everything is the another challenges from the border side, from the AI aspect, if I'm trying to see that the sending the data may be too costly. Okay, suppose I have a mobile, I want to send the data, I want to analyze my data. I have to share the data into that central data center facility. So it is too costly. How that you are sharing, the other persons are sharing, it is collected. So it is the communication cost is high. For example, self-driving cars are expected to generate several TBs of data a day. So you can imagine that how much costly it will be to share the data, to send the data to a centralized setting. Even some wireless devices have a limited bandwidth of power. So even if I'm trying to send the data during uploading and offloading, I don't think that the mobile battery power will help you. Okay. So data may be considered too sensitive. The second reason is that for example, in the hospital, for the defense, for the share, that these data are quite sensitive. Okay. It can't be shared to the some central set. It can't be shared to the some central server. Definitely no one want to release their data to other person. Okay, because this scenario, this is the basically we see a growing public awareness and regulation. There is a specific government regulations on data privacy, so we have to follow those things. So it should not be possible that we should share in the centralized data set. Second one is the keeping control of data can give a competitive advantage in business and research. For example, two industries is competing for the same product. Okay, let's assume in the AI also that OpenAI is also competing, that the other is also competing for the same product. They are trying to same generative model for suppose the share market analysis and the predictions, all these things. If everyone is sharing their data on the server, and from that we will get and anyway that every company has their hacker or other things. So if I will take the data, definitely I have the information of my rival. Rival also have my information. It is very difficult. Okay. So to make a competitive advantage in business and research, these data, the privacy of data should be maintained. So even we are using these data, but we are protecting our data set from the other clients. Okay. So how about each party learning on its own? It's fine. We can keep our data with us, but is it feasible that I have only 10 sample with me? Okay. And another party has 1,000 samples with them. It's fine, they can study, but I have a 10 sample, but these 10 samples are maybe very sensitive, but I am unable to train my model, right? Because the local data set it means if I have a 20 samples or 20 samples or 100 samples, it means the local data set at my site, it is too small to train any kind of deep learning model. Okay, so maybe I will get issues of the AI model like overfitting and subpar predictive performance, maybe non-statistically significant results. For example, medical study, I have 100 samples of new disease, but still I am unable to train those models because these model has the prerequisite that they require a huge data sets. Okay. So does it mean that if the one client has a very small sample, so they can't analyze their data set, they shouldn't have a right to use the analysis? No, we can protect our data set, but we can find a different solutions. Second one is the reason that why each party, why they are not learning by own in on their data sets, because the local data set may be biased. Okay. So not representative of the target distribution. Maybe you have so many samples of the normal samples. For example, in the disease also, non-disease samples you have, and only one or two samples you have a simple disease, or maybe if you have a multi-class, one class have the skewed distribution you have. Okay, what do you mean by skewed distribution? Skewed distribution, for example, you see that the class 1, okay, class 1 maybe in the different cancer type you can see that one type of the cancer you have a 2000 sample, another cancer have a only you have a 50 sample, another have a 500 samples. So generally, even if I will train my model is biased towards the 2000 sample training. Okay, so it may possible that my model get biased. I am not able to learn the overall distribution representative. Okay, So finally, broad definitions of the federated learning. This definition basically it is proposed in the advanced and open problem in federated learning. Okay. If you in such cases, if you see that the those papers that if you have the advanced and open problem in federated learning, this is the first place that they have proposed this exact definition and they started to work on this. So what definition they have given? They have given a federated learning is a machine learning setting where multiple entities collaborate in solving a machine learning problem. It means multiple entities means multiple clients. In the hospital scenario, multiple hospitals, they are collaborating. They are not sharing their data. They are collaborating in solving a machine learning problem. It means they are solving some to train some mathematical model. Okay. Under the coordination of a central server or service provider. There is a central server, but it doesn't take all the data from the different clients. Okay, setting is same, but only thing is data is not with that central server. So each client's raw data is stored locally and not exchanged or transferred. Instead, focused update intended for immediate aggregation. See, few things are very important in the federated learning definition. That is, it will basically leads you on a different research avenues. That is, the immediate aggregation are used to achieve the learning objective. It means one important technique is the aggregation. How do we aggregate these informations? Okay. First one is that how we can maintain the data or how we can share the model information to the server information. Okay. So it's a client raw data stored locally. That is the one important aspect. All data are stored locally. Only thing is that they are exchanging the models information, not about the data. They are not sharing the data. The third important aspect, immediate aggregations. Okay, if your different clients have their different data, they have their own small model. They are trying to train those models, but in the server also they are sharing that the model information. Okay, so how do we aggregate this model information from all the client to achieve a one learning objective? That's a classification problem. We have to do the classification technique. Okay, so defining the characteristics, basically what the definition we discussed, that if the data is generated locally and remain decentralized. So each client stores, if you have these things, each client stores its own data and cannot read the data of the other client. Okay, data is not independently or identically distributed. It should not be. It may be you have for example, if you have a binary classification problem of the maybe a different patient lung cancer, it has a different patient. Maybe this hospital has a different patient. If you see that this is the basically beauty of this learning paradigm. This is TensorFlow I have written. It is basically it tells about that what about the AI model what you are developing at the local host also, and that should be shared to the server. And these information are to be again after some of iteration again it is shared to the client. So we never share these data. We are only sharing these information, and this is the offloading, uploading. Okay. So here it is a server means a central operation or service coordinates that training but never sees the raw data. Okay, it means if you are sharing only this mathematical information without sharing this data to the server, and at this place the basically the aggregation what we are talking about, that the aggregation happens. And what are the technique you are using for the aggregation? Basically it depends on that. It means we can design a different aggregation technique. That is another research avenue. Okay, so federated learning, it in a very simple term, that what it is, in federated learning, basically, it aims to collaboratively train to a ML model while without sharing the data in the decentralized manner. Okay, it means here we have a different client. We are trying to collaboratively train some model Collaborative means I'm giving the training information, that the way the model information here, this, and I'm trying to learn at this place, and again I will share. It means, however, I'm not using the data of I'm not using this data, neither from this data, neither from that data. Individually, they are using their data, but since the model is trained on these data, the information aggregated, we learn from that. For example, one is good in mathematics. Okay, one is good in science also, and the science also, and another is good in the mathematical statistical analysis. We can share and we can work on some project that is called a collaborative way. Okay, it means in the hospital setting, maybe you have only one class sample, maybe you have a 2 classes sample, you have 100 sample, but all about the cancer data. You can train collaboratively, even if you don't have so many samples, but you can maintain without augmentation. You are maintaining the those challenges by using the collaborative learning. Okay, what it does. So it aims to collaboratively train the ML model in the in the basically decentralized setting. So first step is first initialize the model. Okay, it means if I am using the initialize the model means if you are using a neural network, or let's suppose you are using a VGG16, VGG19, or any vision transformer model. The first thing is that randomly initialize those models. What are the architecture? How many nodes you want? Or let's pretend model. I have designed all these. That these all models are same. So same models are initialized at each client as well as the server. Okay. Second, each party makes an updated using its local datasets. Now once you have shared the initialize the model at each client as well as the server. At the server, there is no training happens. Okay. What they are doing in this client, they are training their own data with the help of their own data. Here they are trying to train that whole data, and every client is basically trying to update the model weights using their own information or own local data sets. Okay, so in such cases, once it's not only just a one epoch, they train their this network after certain epoch, maybe 50 epoch, maybe 100 epoch, whatever. For everyone, we have set it all these things. So once it get trained at the local data, after certain epoch, what we will do? Parties share local updates for aggregation. Okay, every party they share these model weights. They have shared this model weight. They have shared this model weight. This. So it is a learned weight of the model by using this local data set. So despite of sharing this local data set, we are sharing the network information. Okay, and once it is shared to the central server, that is called the we are trying to aggregate all the information at the server. Okay, so now server aggregates updates and send back to the parties. What it does, it takes all the information, because since the network is homogeneous, it means if I am using a VIT, here all are VIT. If I am using a VTT16 model, maybe if I am using my customized neural network, it is all about the customized neural network, same at all places. So server aggregates updates and send back to the parties. It means it takes the information all, and there are some mathematical formulation will be done, because I need to aggregate all this information. I can use the average of all the weights. I can use the different techniques. So based on these different aggregation, there are different variant of these federated learning model schemes in the research. Okay. So once we have aggregate all this, currently you just understood that we have aggregated. I will discuss in detail what are the different aggregation technique. Once I aggregated all this, it is shared to the each client. So now you understood. First, I'm giving a different information. Maybe suppose, let's assume it gives a 5, 10, 20, 30, 40 something kind of thing. It may give a 1, 2, 5, 10 something. You have a different information. Here you have it. But once it comes on the server and once aggregation happens, the common weights are shared to everyone. It means, however, I am not taking consideration of this data directly, but indirectly, I am using the informations of the learning weights in these things. So what happened in this case? For example, Suppose this model has trained perfectly. It has a very good distributions of data. Okay. This client doesn't have a too much sample. It doesn't have a very good information. But if all three are very good, so there, if the aggregation happens, definitely these three will dominate. And based on that, the worst learner can improve their learning techniques. That is the good thing about the aggregations. So next, what happens? Once every party has got their weights from the aggregated weight, again they will train. Okay. It means what? These party update their copy of the model and iterate. It means first we did the aggregation and these weights are shared. So everyone has a common weight now in the first round after certain epoch when after first aggregation. So again, I will train these things from these data sets. Okay, again every party will say. So after few talks, again we will do the same activities. So we would like the final model to be so good as the centralized solution, ideally, or at least better than what each party can learn on its own. For example, at last, whatever model it is, definitely if it has a very low sample, definitely it is better than the first version of its own because it has it learns from these weights also. Okay. So what is the key difference between with distributed learning? Because it looks like something about the okay that the way data are distributed across different clients. So why not it is a distributed learning? Okay. Or what is the difference that the why we are telling as the federated learning, why we didn't tell us a distributed learning? See, first thing is the data distribution. In distributed learning, data is centrally stored. Okay. Example in a data center. So the main goal is to just to train faster. Distributed learning basically it utilizes the resources. Okay, resources it means that the computation resources. Okay, so it only the objective of distributed learning. The main goal is to train faster. Okay, and we control how data is distributed across worker. Usually it is that distributed uniformly at random across workers. Okay. So in distributed learning, I'm giving one example. I have a one data set of the stock market predictions. Or let's assume I have a data set of the one car design. I have 1,000 cars and I have a different features. In distributed learning, all these 1,000 informations are at the central server. What it does, it equally, for example, I have a 10 clients. What I will do, 1,000 by 10, I will share all the samples to everyone. It means equally distribution, uniformly distributed. I will uniformly distribute and I will say, okay, just take all these data and whatever training you do, you can do. Okay, that is the distributed system. And it basically it is a distributed uniformly at random across worker. But in federated learning, data is naturally distributed and generated locally. It doesn't have any role of the central server. It's a client choice that how my data set should be distributed while during the training of the model, or should I can generate a locally also. Okay, so data is not independent and identically distributed, so that is called a non-IID setting, and it is imbalanced also. It may imbalanced. Okay, so additional challenges that arise in a federated learning. First one is that okay, we are talking about the data privacy. But still there is one challenges arise in federated learning, that enforcing privacy constraint. We will discuss how it is. And dealing with the possibility of limited reliability or availability of participants. Next one is achieving robustness against malicious parties. So it's fine. Federated learning, it when it comes in the picture and comes in the research avenues, people are thinking that if I'm using a federated learning, my model is secure. No, your model or your data is secure. No, you have to think about from the defense mechanism also. If you are doing in the distributed setting, if you're trying to train the model in a distributed setting, fine, you are not sharing your data with anyone, with any of the client. But One thing, if you have seen that we are sharing the weight of our model. Suppose, and the assumption of these federated learning models are that they are assuming that the server is honest and all the participant, all the client who are involved in the collaborative training, they are honest. But in real situation, it won't happen. Suppose I am the malicious client, I can participate in the collaborative training. And what about, since I can influence your learning mechanism, right? Because I am also sharing my weights. So in such cases, these are the another type of constraint or the another challenges that arise in the federated learning. Okay, suppose that one party will be malicious, then definitely some kind of attack it happens. Maybe for the, I am not a harmful party in that case, but I can understand that, okay, what you are trying to learn it. Okay, and it is limited reliability. It is also availability of the participants also. Okay, so it is, earlier it is too good, the uh, basic learning technique that the Fed AVG and these things, that it is good. It gives a new idea, but still it has a challenges and people have to think about things. So one thing is that different way of federated learning. Okay, that mm, even in the interview and the most of the people, they are thinking, okay, federated learning, it's just a one kind of federated learning, that is the Fed AVG. No, it's not, because there are different way of different setting in within the federated learning. For example, cross devices versus cross silo federated learning. Okay, cross devices federated learning means it's a millions of intermittently available client devices. For example, I have a one server. Now you know that the telecommunication center, right? Telecommunication center, do you think that if I am roaming from here to, for example, I am roaming here from here to Ujjain, or I am roaming from the Jaipur, and I visit the Jaipur, and I will be returning for after some day or something, right? It's not I am permanent there. So in such cases, that the cross device federated learning, it uses in such scenario when you have a million of the client devices. Okay, you have a million of client devices and one coordinating server. That setting is called basically a cross-device federated learning. Then what about the cross-silo federated learning? Cross-silo federated learning is basically you have the same setting, but only thing, limitation, a constraint is that you have a small number of clients. Okay, it may be institution, it may be a date in terms of the institution, you can say maybe you have the limited institution. It may you have a data silos problem of the high, or the it may be the high availability. It means my bandwidth of this server and the communication, it should be like a for a limited sample. For example, if I'm designing some AI solutions and I need to maintain a constant or efficiency in every term, for the limited for the hospitals, if I am within that Punjab region, I'm not going to enhance for all aspects of the India, right? So if you have the limited client, you are providing a solution of the limited client, that is called a cross silo federated learning. If I am working on the mobile device, if I am working on the IoT and intelligent, which is movable and which is, if at the initial stage, if you have the thousands clients, it's not necessary in the second stage you have the 1,000. It maybe you have the 2,000 client. It maybe you have a 90 clients. Okay, so in such cases, it's called a cross device federated learning, because your devices and every configurations are different. Second difference is that in the cross device federated learning, client cannot be indexed directly, so that no use of client identifier. Okay, because if you are working on the intelligent IoTs and all these things which is movable, so in that cases you can't provide a client identification. It's the same thing. Suppose for 2 days I will be in the Jaipur. Okay, after some days uh, I move from the Jaipur to certain other places. Okay, so in the Jaipur location, if you have the server, only for the 2 days I was there, so only for the 2 days my information was there. After that, maybe I won't return back, or I won't visit or some kind of thing, or maybe I visit after 1 year or 2 years. So there's no point of giving a identification number, client identifiers. Okay, so here in such setting, client cannot be indexed directly. Okay, so selection is basically a coarse grain, so its updates are anonymous. You don't have a very fixed kind of updating. But in a cross-silo federated learning, each client has an identity or name that allows the system to access it specifically. It means if you have a dedicated, these hospital maybe at suppose one defense industry, another the defense industry. Since they are fixed, the client identification number is given, and they can specifically involve this training and or participation, all these things. Okay. Next one is that difference. For example, in the round one, earlier what happened that we are training the model, and once we have trained the model, we are transferring the weights to the server. Again, that aggregation happens and it is transferred to these to the client. Again, we are updating at the local side. Here, what happens? Server can only access a possible biased. Okay, it's a random sample of client on each round. It doesn't mean that we are very that we are sharing everything. And large population means most client only participate once. Okay, that is the main thing in the cross device federated learning. Cross silo, most client participate in every round. So every round, if I am training my one model, AI model is there, and I'm training to server, so every time they are participating in the round. But here, if you have the one AI model, it is not necessary that the same clients are involved in the every round while updating the weights. Okay, so here client can run algorithms that maintain local state across round. Okay, so here the client are responsible for training their local data set and sharing the information. So it's since you have the identification number, you can easily identify what is happening at the which client end. Okay, next one is that round two, that completely new set of devices. Suppose in the round one that 5 or 6% they have participated in the training, collaborative training, but in the round two, in the cross device federated training, maybe a completely new sets of the client comes in the picture. Okay, but here even in this thing, round two also, that is the same client. What do you mean by round two? It means see the few epochs you have trained your model at the client, then you transfer to the weight to the server. Again, you return back to the after aggregation, it return back to the client. That is called a one round. Okay. Similarly, for the second round, the same clients are participating, but here it may possible that the 50% are same. It may possible that in the very extreme situation, it may possible all the clients are completely different. So cross-device federated learning, its communication is often the primary bottleneck. Okay, here communication or computation might be the primary bottleneck. Okay, because this is the difference. It often cited it is the primary bottleneck. So another important thing that in federated learning, we have a different mechanism of partitioning the data. Okay, and based on that, different architecture and different settings of the federated learning happens. So among that, one is the horizontal partitioning of the data and vertical partitioning of the data. Okay, so cross-device federated learning always uses a horizontal partition data. Horizontal partition data means that the data sample, everyone, whatever they are sharing, the features are same. Okay, but in the vertical partition data, that if you are using that, you have the sample but different features. Okay, here maybe you have a different samples but same features. Okay, maybe for example, earlier you have a 3 samples but the number of columns are the same. Similarly, the another 3 samples, so it is participated in that way. So the cross-divided federated learning, it always uses a horizontal partition data. So when you are doing a research work, when you are working on such kind of scenario, you have to follow the horizontal partition data, because every time maybe the distribution of these clients are changing, the different new clients are there. So it is optimal that the horizontal partition data sharing we are using. Here, since they are the limited number of the clients are shared involved in the training the model. So here we can use the vertical partitions data. It's not, we can use the horizontal also, but mostly they are, it's beneficial that we can use the vertical partition data. So overall, what is the summary till now? The summary is that federated learning definition, we know that the without sharing, we are trying to train the model in the decentralized data setting. Okay. Second one is we are trying to learn the model collaboratively. And among that, we have the two mechanisms of the data sharing. One is the vertical partitioning, another is the horizontal partitioning. So we have a different setting of the federated learning. For example, that the summary shows the cross-device federated learning and cross-silo federated learning. So it's not when you are writing a research, don't write a randomly any word. Okay. In which setting you are working, that terms specific, that technical term you used. Otherwise, everyone is writing like just a secure federated learning. Federated learning, we are, if even the student, when they are talking about the how you maintain the security of the model, they are talking about the federated learning. See, federated learning gives you to learn the model in a decentralized data sharing, but it doesn't mean that it will give you a completely secure model. You have to think about the adversary also, how to design the defense mechanism for these models. So cross-device federated learning, the key points are there. It has a massive number of parties, up to 10 to the power 10 also. While the cross-silo federated learning, it has a very limited parties. That the parties means clients, 200 clients. It has a small data set per party. Could be a size 1, okay? Because these are the very small edge devices, all these things. Medium to large data set per party, because it's a dedicated clients are there. Limited availability and reliability, because maybe I am participating in the one round and I'm malicious, I have given the information. In the second round, I am not there. So you can't identify that who has done the attack or who has done drifted the model learning from a one perspective to another. So some parties may be malicious. Oh, or generally in this, the generally since it is a limited number, generally it is assumption that the parties are typically honest. See that if all the hospitals are there, we are assuming these hospitals are always honest. What they because they need a solution for themselves. There is no point to do the attack. But here it's a mobile system. Okay, and different edge devices. It's not only the mobile, any kind of edge devices. So I'm not dedicated. I don't have any identification number to this server. So maybe I can be malicious only for the interest to learn what is happening. But maybe that I have an alternate motive. So generally some parties may be malicious, but it is generally typically it is a honest setting. The next one is that the server the next difference, that is the server orchestrated versus fully decentralized federated learning. Okay. For example, server orchestrated federated learning, you have a server client communication. Okay. It means you have a client, you train the model, then you use the server for the aggregation and other things. So it has a global coordination and global aggregations. Okay. So their server is a single point of failure and may become a bottleneck. For example, just like in the airport scenario, suppose if I am designing some solution for the airport, in between that you have seen that once the server down, that the people are waited at the different places, they are waited for the long time, right? So in such scenario, what happened? If server is failed, the 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 client doesn't have any information, they can't have the information, or they can't train their model in the collaborative way. Second one, if the server is malicious, because it's not 100% sure that server can't be malicious. Suppose in the server, wherever you are sending your model information, it is malicious, it can easily attack, it can easily the your decision from a desired decision. Okay. So here the most crucial point is that the server is a single point of failure, and it may become a bottleneck. Okay, because even the aggregation happens here. If aggregation doesn't happen here, we don't get the next information in the next round. Next one is the fully decentralized federation. Most of the people are working in this setting. Okay, so Few works are in this setting also, but still they have this challenges. Still, it is ongoing in this area. The research are still ongoing. So fully decentralized federated learning, you don't have a server. What they are doing, every client is sharing with their neighborhood. It's a device-to-device communication instead of server-client communication. Here, you don't have a global coordination. You have a local aggregation. For example, I am sharing the information to this and this. I know who are in my neighbor. Okay, so I am taking the information, I am sharing and uploading the information from here to here. So I am aggregating the information from these two. These client has aggregated the information too. So it's like a peer information aggregation. So it naturally scales to a large number of devices. Okay, so it has a very wide scope of research, but few constraints. We have to think about the mathematical side also. So in the federated learning terminology, that what are the main terminology, whichever research paper, whichever uh, avenues, if you go, you will heard these points. First one is the client. What are the client? Who can become the clients? That is the compute node also holding local data and usually belong to some entity. Okay, it can be a IoT devices, it can be a mobile devices, it can be a data silos, it can be a data centers in a different geographic region. Okay, now you understood that if I am talking about the client, it doesn't mean a one computer system. Okay, it doesn't mean a one hospital. It can be anything. It can be a small IoT device. It can be, for example, if I want to treat as a mental health. Okay, so it can be my different sensor on the brain. It can be on the information from the smartwatch, which I smartwatch. You can have the some wristband or some kind of thing. It can all can be treated as a client. Only thing is that if they are holding a some local data, okay, and it usually be, you can have a data silos, you have a data centers in different geographical regions. Based on the large scale, it can goes on. Okay, so the second terminology is the server. What is server? Basically, it additionally compute nodes that coordinate the federated learning process, but don't access a raw data. Okay, usually not a single physical machine. Okay, we can't say that, okay, this is a server. It doesn't mean that it's a GPU server. Okay, it's just a one computing node that coordinate these process. Okay, it can be a one computing resources, it can be a very large data center, it can be anything, but uh, it's a basically one coordinator who is dealing with all these clients. So what are the characteristics of the federated learning setting? See, in the overall, whatever I have discussed, if you understand this table properly, then you can understand what is the limitation, what are the drawbacks, in which setting what should I use. And these are basically, if you see the advances and open problems in the federated learning, this paper on the archive, you will get all these information, because it is very, in a very good way, they have tabulated all these things, those who want to explore the federated learning, and after that you can go to the advanced techniques also. Okay, so characteristic of the federated learning setting, first what we will do, that the data center distributed learning. Okay, cross silo federated learning, cross device federated learning. Okay, based on the difference, we can distinguish among all these things. If I'm talking about the setting, what is the difference among this? With a data center distributed learning, the setting is that training a model on a large but flat data sets. Okay, clients are compute nodes in a single cluster or data center. Okay, if I have a data center, I can have a multiple computing nodes that can be treated as a clients, or generally we are giving the all that data generally uniformly distributed among the data among all these clients. Okay, that is the data center distributed learning. Cross silo federated learning, it training a model on a siloed data. Okay, clients are different organization, maybe a medical, financial, or any data center in different geographical region. It can also possible. However, the cross-device federated learning, the clients are a very large number. For example, mobile device, IoT device. It's just like, for example, I have designed one AI system which is collaborative learning from the multiple medical institutes. All the aims on the country, all the aims within the India. Okay, that can be a one setting because you have a limited number of aims. If I am involving all the other hospitals also, but it is specifically meant for the hospitals, right? In the cross-device federated learning, you don't have a restriction on the IoT devices. It can be a phone, it can be a sensor, it can be any other things. Okay. Second one is a data distribution. Here, data is centrally stored, so it can be shuffled and balanced across client. See, it is the balanced across client. Any client can read any part of the data set. Okay, because it is maintained on the central server. So if I have access, I have a right to read the data. I can read all the data. If I have access to share the bills, if I have the access or to manipulations or those things, I can do easily. Okay, it's not a purpose for this setting is not a purpose for the data security. It is basically to enhance the utilization of the computation resource, and basically it distributes the task into a multiple task so that it can be completed in a faster way. Okay, that is the objective of this type of setting. Here, data is generated locally and remain decentralized. Okay, whatever data it is there, it is always on the local host. So each client stores its own data and cannot read the data of other client. Okay, it cannot read of the other client because I don't have access to interfere in the other client information. So data is not independently or identically distributed. Okay. So next one is the orchestration. It's basically centrally orchestrated. Okay, because you have the central server client setting. Here, a central orchestration server service organizes the training but never sees the raw data. It only has work as the coordinator. Okay, here is a central orchestration server, but it involved in organizing the training, not about the seeing the data, what are the raw data. Okay, it performs only the aggregation part. In terms of wide area communication, what is the difference? There's not fully connected client in one data center cluster. Okay, it is connected. So there should not be a difference. Here, typically hub and spoke topology, with the hub representing a coordinating service provider and the spokes connecting to the client. Okay, it's basically the hub is basically without any data or the coordinating server, and the spoke, it means a client which is connecting to the client. What about the data availability? All clients are almost always available. Okay, that's why they can see each other's data. Here, only a fraction of clients are available at any one time, often with others in the other round or the other variations. Okay, here also all clients are dedicatedly attached in the cross silo setting. What is the distribution scale number of clients if I am talking about? It should be typically 1 to 1,000 clients. Okay, based on the bandwidth, you can connect more clients, but typically it's a 1 to 1,000 clients. Here you have in the cross silo, because I talked about is in the small setting. So it's typically 2 to 100 client. You can design such kind of architecture for a 2 to 100 client if you are assumed. Here it is a massively parallel, up to 10 to the power 10 client. Okay. So generally in the telecommunication sector or other sector, if I am talking about too much IoTs and the information, in such cases, we are using this cross-device federated learning, because we know that every time I don't need to maintain that much memory. I have a limitation, but since the number of the client will be fluctuate from the small to higher, so I can easily adaptively adjust all these computation resources. Another difference based on the addressability. In both data center distributed as well as the cross-silo federated learning, each client has an identity or name that allows the system to access it specifically. See, in this setting, it is very easy to identify which one is the malicious, because everyone has the some identification number, even the hospital has some registration number. Based on that, we know that who are the collaborative clients. Okay, so it is easily detect. Not very easy, but compared to that the another setting, it is quite easy to detect because you have the information of that who are the participant in this training. Okay, but here client cannot be indexed directly, so no use of client identifiers. In terms of client statefulness, each client may participate in each round of the computation, carrying state from round to round. Okay, it means sharing the information based on the round basis. Epoch is different from round. Okay, if I'm training a one model and I'm talking about 50 epoch, it's when it is at the local host. Okay, but once you train the model and you transfer the weights to the central server or the some coordinating host, so and then after aggregation it is written back to that is called a one round. So it should not be 100 round or something. The epoch is different, round is different, and it is very important that how much time we are taking in the round, we need to measure those things. Okay, that is the, if you are able to reduce those communication costs in this such type of setting, if you are maintaining the, if you are trying to maintain the or handle the address the malicious client in such setting, it is a good research avenue. That is a good contribution in this area basically. Here it is a generally stateless, since each client will likely participate only once in a task. So generally we assume a fresh sample or never before seen clients in each round of computation. Okay, that is the difference. So primary bottleneck of these models distributed, it is computation is more often the bottleneck in the data center, where very fast network can be assumed. Because we are assumed that the whatever the server, it has a very high bandwidth and the communication is quite faster in that way. Even if you have 1,000 clients also, you have the very faster your bandwidth and every communication is very fast. Here might be a computation or the communication. It might be we are not worrying about that we have the very fast computation or communication, but definitely we are talking about that we have this as a bottleneck. Okay, because even if you are taking a round, if you are suppose you are taking 100 client, and if you are using a very big architecture in each client, then definitely it can be a bottleneck, right? Because we are sharing the weights of the model. And if I have every client, we are using a model with a billion parameter, and it means every client will share a billion parameter, and up to suppose 100 client is sharing each client 1 billion, so it's 100 into 1 billion parameter they are sharing, the 100 billion parameters you are sharing. So definitely it can be a computation or communication bottleneck. So it might be. But if you are using a very small network, definitely it won't be a bottleneck. Here communication is often the primary bottleneck, though it depends on the task. Generally, federated computation uses Wi-Fi or slower connection, because in the mobile device, whenever we are roaming here, okay, that suppose if you are moving from one state to another, or maybe you are from India to somewhere else, okay, so even in that within the India you are you have the roaming, right? So under these base station, your identification comes in that whenever you are moving from one base station to another base station. Reliability of the client in the both setting, relatively few failures. Okay, but here it is a highly unreliable, because 5% or more of the client participating in a round of computation are expected to fail or drop out in the next communication. So the solution here, it is quite unreliable, because you can't because if the same clients are participating at least up 50% of the round, 50% in the model training, then it's fine. But generally it is not the same condition happens. So data partitions access. Here data can be partitioned or repartitioned arbitrarily across the client. Okay. Here cross silo partition is fixed. It could be example partition horizontal or vertical. You see cross silo where you have a limited number of the client. You can choose any type of data partition. Okay, you can choose any type of, either it's your choice. that it depends on the what type of the data. You can choose the horizontal partition, you can choose the vertical partition. But in the cross silo, generally it's a fixed partitioning like a horizontal partitioning. Okay. And these all things are basically, if you go detail in these things, it is available in this paper. So federated learning is a booming topic. Okay. If you see, it started in the 2016, but nowadays if you see that it goes, there are a lot of development in the terms of the communication, in terms of the aggregation. Even the people from the maths discipline also, they are trying to analyze the convergence of these models, that even in the communication round, how they are behaving. Okay. So in 2016, the term federated learning is first coined by the Google researcher. Okay. Then 2020, if you see that more than 1,000 papers on federated learning in the first half of the year, compared to just 180 in 2018. So you can see 2016 to 2018, you got only 180 papers. And suddenly 2020, if you compare that, the 1,000 papers are compared. So you can easily understand that how people are working aggressively in the federated learning. Similarly, now as in the large language modeling, as well as the agent system diffusion model, there are a lot of development, and they are, once they are developing all these things, they switch to the federated setting also. Okay. There are several open source libraries are there under development. The few are under development, few are still updating, and but still there are a lot of libraries that you can use to design such kind of setting. That is the PyShift, TensorFlow, Federated, Fed, Flower, Substrat. And since federated learning is highly multidisciplinary, it involves machine learning, numerical optimization, privacy and security, network system, hardware. So you can analyze all these type of different fields. They can work in this this type of topic. And if you see that these information we got, that the next generation of AI, that folks, they have gone there. It's a highly people from the who belong to the privacy and security, those who are working on the cryptography, they also come with the how homomorphic encryption we can use in the initial layer. The network system, those who are working in the pure networking, they also involved in, nowadays they are involving in this, how to make a setting in a distributed and the federated way of federated learning they are utilizing. So these are the other open source libraries which you can use for a federated setting. That is the Fed, TensorFlow Federated, Flowers. Here in the Flowers, if you see that the Fed AVG, the baseline is already implemented, only you have to import those things. Okay. NVIDIA Flare, OpenFL, Intel, Fed, ML, PySift. So you can understand easily that only term is there, the federated learning. First, people try to develop one model. At that time, these TensorFlow federated, those things are not there. They have designed from the scratch. Since it is very useful, different industry involved to design in this library which can provide these settings. And now they are trying to improve these libraries by using a different mechanism, that they are trying to incorporate a different techniques as well as the recent model also. So for teaching or prototyping, you can use, you want to demonstrate, you can demonstrate to your students, you can use in your research without going to the scratch coding. You can use this setting, and then you can customize or you can make the modifications in the model. So it means you, for designing the number of clients, the one server number of clients, how the communication round. So these libraries are very helpful with that. So frameworks such as TensorFlow Federated, Flower, PySwift, OpenMFL, it helps manage training, communication, and experiment orchestration. So you can analyze, you can understand, you can demonstrate, and you can customize all these things. So common contribution areas in federated learning, if you see, the common contribution area, if you see that the most of those things, it goes to the model aggregation as well as the convergence reductions. Okay, most of that, 15 that if you see this low, because see, client number of client maybe increase, maybe decrease. We are trying to develop a scalable solution, but the one thing is important, that aggregation aspects, how you are going to aggregate. Okay, it's not only average. The same thing, the billion parameters is fine. You will do the average. It takes a much lesser computation. But to transfer those billion parameter to server, it took a long time, right? So we need to make an efficient communication latency also. Okay. Next, if you see that the few research are going in the same setting, heterogeneity. Few are working on the how to even secure this federated learning. Some are working on the communication cost, computation cost, fault tolerance, learning quality, how to understand the data in a better way, scalability, personalization. So these are the different, you can think in that way that these are the different problem statement within this federated learning. And you can choose anyone based on your expertise, based on your interest. So application of the cross-device federated learning, if I am talking about, basically what makes a good application if I am using, that is the on-device data is more relevant than server-side proxy data. Okay. You have to think about that. On-device data is privacy sensitive or large. Labels can be inferred naturally from user interaction. Okay. What are the corresponding applications? It can be helpful in the language modeling for mobile keyboards and voice recognition. Okay. On-device data is privacy sensitive, then you can use the image classification for predicting which photos people will share and so on. There are a lot of applications are there. So another one is that if you have seen that the Gboard, okay, that is the next word prediction. Maybe you have used or maybe you haven't used those things, but these are the Gboard is the one invention that basically it detects the next word prediction. What is that? What backbone they have used? They have used the RNN and they use the federated setting to train all these models. So what they got in such ways is that the better next word prediction accuracy is approximately plus 24%. Okay. And more useful prediction is to plus 10% more clicks. So they have compared with the normal baseline RNN and all these things. It completely dedicated data at one place and in the federated setting, how it improves. And this paper, if you see that it is there, federated learning for mobile keyboard prediction, and industry are using those things. So still, they are trying to improve on this. They are trying to make it more robust on that way. So other federated models in Gboards, if you see, that if you open that the Gboard and you can explore all these things. If you see that the first one is the emoji prediction that they have. See, these are the different application we are working on a 1-1 research paper. Okay, if you see that the Ramaswamy et al. Federated learning for emoji prediction in a mobile, and all this very good solution they combine together and try to improve. So it is a in the Gboard model, all are integrated. Okay, so in emoji prediction in the federated setting, they got a 7% more accurate emoji prediction as compared to the dedication model training. Okay, prediction strip clicks plus 4% more, 11% more user shares emojis. In such cases, I know it is only these emojis are besides me only. So I can design, I can make it, and I can share because it is not going on the server side. So that's why if someone say, okay, make a face and different face expression and share to the sub server, no one is doing that. However, nowadays, unconsciously or unknowingly, people are sharing their data on the server in a different way. Because, however, the data privacy is very important. In a long way, every company, every product, they are trying to develop that how to secure those data. It should not be revealed in the outsides. Okay, for example, currently in the India they are working on the mental wellness, as well as the US are also working on the mental wellness. See how it is it is basically a business industry. Okay, suppose directly US doesn't have, US or any other country doesn't have access of Indian data. Okay, but if some Indian dedicated people who is collaboratively working and indirectly without taking a consent, if they are sharing the Indian data to the another industry, another country market, what happens? Suppose I am also working on the solution and other person has their own country information as well as the another country information. Definitely the modern training and everything is get affected, and based on the drug discovery, it impact the huge markets. So now you can understand what is the privacy of the why data privacy is important, why we are always talking about the data confidentiality should be maintained, why the government regulations are coming. Okay, so there are different way, not only the healthcare sector, every sector. Even if you are the defense designing, if I am designing some product for the defense mechanism, I need to make secure data. That's why in the defense mechanism, they are not sharing the data. You have so many public data set of the normal image and natural voice and those things. Have you find any the open sources for the defense data? You know, you will never find out these things. Okay. So discovering new words, predicted discovery at what words people are typing that Gboard doesn't know. Okay. So in such cases that the prediction is very high because they have done the use the collaborative training despite collecting all the data together. One is the cross-device predicted learning at Apple. Still, Apple is working on these things. Okay, they are trying now, apart from the cross-device federated learning, now they are working on the personalized federated learning. Okay, because recently we have the interaction, so we found that the 2026 they are working on the personalized federated learning, and they have developed a solution. Still, they are trying to improve it. So, how Apple personalizes Siri without hovering up your data? You can understand those things, right? They are personalizing the Siri because what every task when you are giving, it is trained on your own data. Okay, and based on that, it maintains that track. For example, if you are using a chat GPT, let's take a very small example. Everyone has for example, if you are using uh, the price after taking some subscription or something, you are giving a data. Okay, and see that it is not shared to the another one, but after every searching technique, it is maintaining the information about you, and now it can be personal at any time. If you ask some question based on your search history, based on your whatever you ask, based on it can refine it. Okay, so it means basically they are trying to personalize by the user to user. It, at the first stage, it may give the random useful information, but it's a random. It is not related to completely you. But after certain searches, it will do. So this is called the personalized setting or the personalized learning algorithm. Okay. So here what happens? Instead, it relies primarily on the technique called federated learning. Apple's head of privacy. Okay. First thing it gets to the privacy, and second, it goes for the personalization. So that if you see the tech giant is using a privacy preserving machine learning to improve the voice assistant. Okay. So these are the research development which industries are working, not only the academic researcher, but industry is also working. If you talk about the cross-silo federated learning, it is Intel is involved on this. Then if you see the UPenn Intel patent to use federated learning for early brain tumor detections, okay? Is machine learning for tumor research at odds with patient privacy, not with federated learning? So every time the cross questioning about the privacy and all these things happens, and based on that the new solutions comes, and these all information, if you see that these are the references from there, these are the cutting have taken. So it basically, if you see whether it's a healthcare sector, whether it's a defense sector, whether it's a any any kind of that the autonomous devising system of maintain, we are trying to do even for the household assisting techniques, because see in India we have multiple people in our house. Generally we have our grandfather, grandmother, or if not, at least we have the mother, father, some senior people we have in the most. However, few still we are using the nuclear family, but few families it's still you have the neighbor you can talk it. But in the abroad, you don't have such gathering in the home. Okay, so in such cases, industry are more focused to design some personalized, and now they are trying to infuse the emotion in such cases. Okay. And if I am using the server setting, that the centralized server, do you think that it get personalized? No, it won't get personalized. Okay. So after certain step, I have to deploy, I have to make it personalized setting. So federated learning plays a very huge role in this thing. So when the first basic algorithm is there, that the FedAVG, the first baseline algorithm, the first algorithm in the federated setting, the FedAVG algorithm. And generally, most of the modification, what we are talking, just discussed in the previous slide, that what are the contributions, like aggregation, like security, like communications, and different aspects we have seen that in this direction you can do the research. So the baseline algorithm FedAVG. Now you can easily understood what I am going to speak about that. Okay, because we have shared the different terminology, we have shared the what is the process. So now, if you understood those process, it is very easy to write the code for the pseudo code for the FedAVG. Okay, so generally whatever federated learning we have designed, or the any advancement we will do, we are comparing with the FedAVG and all these different versions. So this is the one baseline for any federated learning approximate. What it does, we understood from the data and the pictorial way what is happening. But how do we write that, how the loss function, because we are the AI developer, we are from the computer science, we need to write a code. Okay, we understood that what is happening. So what it does, the basic notation, if you see, we consider a set of K parties. K parties means K client. And you can easily design this thing with using a now different open source libraries for the related to the federated learning. And each party K holds a data set dk of nk points. Okay, so every client has their own data sets. If I'm talking about the combined data set, suppose I have to represent a combined data set, it means I can represent a D is equal to D1 union dk up to all client data. Okay, that will be the joint data set. And if I'm talking about the number of points, it is a all client sample. If every client has an nk sample up to the k equal to how many number of clients it has a sample, that I will say that is the total number of point, or you can say the total number of samples. Okay. Now we want to solve the problems of the form, because see, federated learning is what? It's fine with the distributed setting. But if I am designing a classification algorithm, what is our objective? In the classification algorithm, what the objective is that we need to minimize the error, right? Whatever the cost function is there, we need to, if the cost function is in terms of the error, then the major objective that I have to minimize those cost functions. Okay. So here only one difference is that f theta d, d is basically we have to find the optimal parameter theta such that this is the minimum. Okay. And what about the f theta d? It means in federated learning setting, for every top, that is the summation of k equal to 1 to k. That is, if you see that at the server end, nk upon n. N is what? Total summation of all the clients, right? Nk upon. So it helps you in the normalize fk theta k and fk theta t. It is if I am representing fk theta dk, it's at the local host. And this is basically a combined cost at the server side. And theta is what? It's a model parameter. It may be a weight of logistic regression, may be a weight of neural network, it may be a weight of ResNet, it may be a weight of Fission transform, or any kind of thing, whatever network you are using. So this covers a broad class of machine learning problem formulated as empirical risk minimization, because we are trying to minimize all these things. Okay. So it is not that the federated learning is related only with the deployed. Any machine learning model, if you are using in the collaborative setting and you are using the same concepts, it is called the federated learning. So that's why it is called a learning paradigm. Okay. So algorithm, if you are writing, it means whenever I am designing or whenever I have to do some modification, I have to think about this part and this part, how to do this. This is the aggregation, how I should do this aggregation. So first thing, the client update k theta parameter, that may be at the batch of the batch size. If you kept the p, number of local step cell, learning set, rate eta. It means a batch size that you have a small data samples, right? So you can train the model in the batch. for each local step 1 to up to L. That is the steps L. It means epoch if you are talking about. You can use a mini batch of B example for decay and update. That is the basically a back propagations when we are updating a theta minus learning rate into a gradient of those value, right? Only thing is there, since you are using a batch normal batch data, so nk upon B. Once you train this model, send theta to server. Once it goes to theta, first parameter client sampling rate, we know that so initialize theta. So initially first initialize theta and transfer all theta to every client. And then you have to do this after the client update, you just do this aggregation and then again you transfer to the clients. Okay. Here for L equal to 1, rho equal to 1, it is equivalent to classical parallel SGD optimization. Okay. Updates are aggregated and the model synchronized at L step. If you have a L is greater than 1, this, each client performs multiple local SGD steps before communicating. That is the difference. So if you need to modify or something, you can do here, or the aggregation steps. You can change the aggregation steps. This is the FairDBG algorithm. They have tested with the different learning rate 0.05, 0.15, 0.25, all these things. And they find that the FairDBG with L greater than 1 allows to reduce the number of communication routes, which is often the bottleneck in federated learning, but it still allows to reduce the number of communication routes. Here, it empirically achieves better generalization than parallel SGD. Converting to the optimal model can be guaranteed for the IID data. If you want to study more in detail, you can go through this paper, which 2019, 2020. Then you can study those who are want to work on only on the convergence and optimization type. They can refer this paper. But issues arise in strongly non-ID data, and it is still a open problem. People are still working. So they will see that what it is. So one thing is that the fully decentralized setting. So we can derive algorithms similar to FairDBG for fully decentralized. Okay. Currently, we are not fully decentralized setting that because we are transferring the data to the server side aggregations. Okay. So let G is equal to 1 to K E be connected undirected graph where nodes are party. It means you can think about in terms of the graph, you can think that how to design the graph without server, how we can learn from our neighborhood. Okay. So for example, given model theta theta k, each party w theta correspond to a weighted aggregation among neighboring nodes. So if I'm talking about the neighboring nodes, I don't have any server or any coordinated host. Okay. I'm always learning from my peers. So if I'm learning from the peer, how can I design this whole architecture in the graph format or some other format? It's not only the graph, you can think about any other mathematical aspects also. So this is the fully decentralized. If you are fully decentralized, in that cases, the only thing is that the same algorithm is there, only you don't need to transfer. If you see in the previous that you have to send the theta to the server, here it is not there. Okay, it's only the decentralized SGD alternates between local update and local aggregation. Okay, because you have the peer, so it means at the peer you have the aggregation. You don't have the server aggregation. And doing multiple local step is equivalent to choosing some of the rounds. So the convergence rate depends on the topology. The more connected, the faster. But one thing is that if it is a more connected, definitely it is the faster, but you require the memory space also. Because if in the large scale, if you are making a 1,000 or 10,000 clients are there, and if I am assuming, for example, if you have the n clients, and if you are assuming all are connected, so it means NC2 communications lines should be there. So it's NC2 communication should be there between all n clients. So that is the computation cost. So you can think about how to reduce all these things. Another thing is the what private information might an actor learn in such cases. Basically, if you see the whole information that all the clients are there, they can do the federated learning, all these things. Model development has happened here that engineers design the one initialized model, share all the model. Collaboratively, they learn. Once the model is fixed, they can be deployed to the edge devices only for the inferences without training. Okay, if they are involved in the training, if I want the solution that this is the final solution that can be given to all, and it is only used for the inference, so it can be the model deployment. So the whole thing is that if you see that the first is the model designing, model development, model training, maybe in the federated setting or any other setting, but at last you have to think about the model deployment. So it's a like a from the product development point of view. So what private information might an actor learn with these access to? For example, the device, this is the client devices, okay? It may be a network, some kind of thing. So it's not rigid only the IoT devices are there. These are the basically network where the communication happens. So you think about all these setting and you are trying to optimize all these things. I think till now, I think I have done. So basically, I already told about these are the server and the release model and the matrix. And then it is that it can be deployed on this thing. So in the one complete product development, that if you see that you have to think what are the IoT devices you have, or you can use, or during training you can design by using a library that you can 5 clients, 10 clients. You have to check the threshold value. Okay, it's not a suddenly you have designed 100 client and you are checking that why my model is not working, because every client has it's never the universal solution. We have to think about the threshold. So we can think about the threshold, that how many client, up to what client we are able to solve it. And then once you have trained, this is the server, these are the here you have to see the model metrics. It's not only about the training, you have to maintain the performance also, and then once it is performed, you get the deployed models. Okay, so what should be the network in the, if I am saying that the server, the device, the network, and the deployed model, what it can be, what is the selection? It's up to you what you are trying to select it. Okay, but what are the challenges with this federated learning? The first challenge, dealing with the non-ID data. It means not the identically distributed data. In such cases, client drift happens in the federated AVG. Okay, what is the client drift? For example, I know that these orange are client optimization and this is the true optimization. Okay, I'm trying to learn it collaboratively, client 1, client 2, all these things. These are model I'm trying to learn and aggregate here. I did all the SGD update and everything in this way. But when local data sets are non-ID, okay, non-ID means maybe a skewed distribution, maybe a completely heterogeneous setting. Okay, for example, one client has a completely different data set. For example, you have the lung cancer data set. Another client has some other skin cancer data set. It's a heterogeneous setting. Heterogeneous setting can be happened in a class basis also. Suppose I have taken a one class 1, another has a class 2. Some rare disease class have only 5 sample, other have the majority 2000. So your model is biased toward the higher samples, right? So definitely it's a client drift. It's a drift problem, and there's a different way that you can think about that the data drift, or which type of modeling you want to do. Based on that you can do. So to avoid this drift, one must use fewer local updates or a smaller learning rate, which hurts convergence. Otherwise, you can use a different solution also. That can be one research area. Okay, so these are basically another challenges, that the learning for non-ID data is difficult, slow, because each party wants the model to go in a particular direction. Okay, and that can be in such scenario that non-ID setting, malicious client take the benefit of these things also. It can drift the whole decision towards its own. Okay, and it can be a malicious, or it is not useful at all. It deviates from the original decision. So if data distributions are very different, learning in a single model which performs well for all parties may require a very large number of parameters. Okay. And another direction to deal with non-ID dataset is thus to lift the requirement that the learned model should be the same for all parties. Okay. It doesn't mean one, either you can say one size fits all. It never happens, right? So Instead, we can allow each party K to learn a potentially simpler personalized model. That's why the personalized federated learning, transfer federated learning, it comes into the picture. Okay. Any question you have?
Dear
Okay.
participants, if you have any question, you can ask in chat box. You just post your questions in chat box so ma'am can reply. Okay, ma'am, you can continue.
Okay. If you don't have anything, see these the basic challenges with the federated learning. And if you see that, I think the another thing is the privacy issues. Okay. We will discuss in the tomorrow session also. Maybe Dr. Abhinav will come, or maybe I will come with some demonstration. But the major challenge is the first challenges is that the drift, and still it is a open research problem. Okay, so another challenges is that the privacy issue. Why it's so? Because see that first thing is that the membership inference attack you can easily do. Why it's so? For example, we are not sharing our data, it's fine, but we are sharing our model weights. But model weights, what does it mean? Suppose you are giving me all the network model layer by layer. You are sharing the whole weight matrix. If I will change one weight row, I am a one client which is a malicious. I have trained data in a completely different way, and since it is at the server place, it's aggregated. Okay, W average, that is the all the taking all the weights of the each layer, doing the average, and then it is passing to what to the each clients. So if I am the malicious client, I'm passing the malicious weight matrix, and you are sharing since you are aggregating, I am influencing indirectly. So after one or two round, I am easily to get what is your model architecture. Okay, and once I got your model architecture, I can use the inversion technique to generate your data. Okay, at least I can generate your what data distribution. So this type of attack. Second thing is that if the server is malicious, suppose all the clients are not malicious, at the server it is malicious, it means it can deviate the decision of all the clients. So that is another privacy issue. So sometimes the member inference attack, these are the different attack. So few research avenues is there. What are the different attack? What are the privacy concerns are in the federated learning or these private models? These are AI models. So few people are working in that cases. Those who are interested in the different adversarial training or these things, they can go through this paper. Second one is the reconstruction attack. Basically, it tries to infer some of the points used to train the model. Example by differencing attacks. Okay, I can infuse a one at the client side or the server side. At the client side, I am using some malicious sample, and I can train my model in that way. Also, so it also affects that when you are trying to reconstruct. Also, it can be easily attacked. Federated learning offers an additional attack surface because the server and or other client observe model update, not only the final model. Every update, because every round we are communicating. It's not that one time we have trained and we have shared, and only one time you are the host computing source that it shared the final update rate. No, it is round by round communication. So between a round, I have easily that either I can target the communication links, I can target the weight in terms of the either client side, either server side. There's a lot of open loops are there that where we can easily attack this model. So the basic fidelity is not completely secure. Okay, so claiming that only applying the federated learning setting and you are claiming that I am developing a very secure model, it is not secure unless you have handled these type of attacks. If you address in your model, if you address this attack and you have modified the algorithm in such a way that even your model is robust against this attack, then you can claim for such type of attack, my model is robust. Okay, otherwise you can't claim that it's a universal secure model. Okay, some other interesting topic in the federated learning, if you want, that is going beyond empirical risk minimization formulation. There are tree-based method, online learning, Bayesian learning, vertical data partitioning. Those who are interested only data side research that how to solve such issues, they can go for these people. In different partitioning technique, they can design. Second one, the compressing update to reduce communication. Those who are interested in the communication side, they can contribute, they can go through this paper. Those who are willing for the fairness, for the ethical side of that, there are 2-3 papers are there. And the security side of federated learning also few are there. These are the, and other few recent are avenues are there. We can discuss it later. Okay. I think I have done. Now you have any questions? Do you have any questions?
Ma'am, I think in chat box you can check one question is there. So from the participant sides.
Okay.
Hmm.
Ma'am, any winter internship in IIT Ropar during December? There's only one question.
No, no,
Uh,
about that one question also, madam.
Suppose multiple banks collaborate to train a fraud detection model using this model. See, yeah, it is very good questions. Okay, still already the research happened in this direction, because one is the you are talking about the model poisoning. Okay, that one is the very other haven't encountered. So for model poisoning, we can do that for the inversion, that instead of the even for the sharing the data and any other distribution, what we can do in the central site server, that we are trying to generate a distributions. Okay, there's a model inversion kind of thing, that from the first we train the model, and through the inversion we can distribute the data. So some data is there on the server side, but it is a generated data set, it is not the private data sets. Okay, and for that we need to solve these issues for the rural bank and these model updates. Unusual, it is called a drift. Okay, a sudden drift. For example, I'm giving a basic example, forget about the predictive learning. For example, I have designed a one machine learning model, right? I have taken all the static data, it's not a dynamic kind of data. Suppose that model you are trying to use for the dynamic environment, and sudden changes will come, for example weather forecasting or any kind of thing. So in such cases, that is counted as a drift. In such cases, we have to use a adaptive training method. It means to learn a drift, or according to the drift we need to retrain the model. Here when you get, you can use first this type of attack. First you have to find out that how to handle, because we know that few possible attacks can happen and it can come into any category. So for there's a technique for the drift detection. So it's not helps only at the aggregation phase, because you are asking about can we, if we choose the aggregation, different aggregation algorithm or something, can it be done? No, only aggregation algorithm won't help even if you modify it. Okay, you have to think about the model inversion side because we have to design a defense mechanism. Is it fine?
Sure, ma'am. So participants, if you have any other questions, you can put your questions in chat box. So next
for the
one
other
minute, ma'am,
question,
next 1 minute, ma'am, is available for answering your questions. If you are not posting any question, it means that there is no question from your side. Ma'am, one more doubt is there.
yes, I have gone through. How do you distinguish between legitimate distribution drift and slowly? See, that you can't say that drift is drift. Okay, and based on the drift, you can identify that generally for any attacker, there is always a background for that why they are doing. Suppose if it is a very confidential or sensitive data, either they want to learn the data. So based on the drift, that you have to see the distribution of the drift, because some are doing the slowly, definitely it won't come into the at the first round or something. So initially few methods are there. If you I think Dr. Abhinav has a certain paper that few attacks prone, you can't say that if I have designed it will handle all these kind of attacks. For a small drift and for the past, to identification this, you have to train your model by generating such type of the attacks. Okay, that if sudden attacks, how the distribution look like. If it is slowly poison, how it look like. Then how I should solve the model poisoning. How should I solve the uh, like one more attack is there, that is the black box or jailbreak type kind of attacks. They can also use those things nowadays. Since I am from the optimization also, so if I can generate a different type of attack, not a specific attack, mixed kind of attack, your model, however prone your model, you won't able to detect those things. So it means you have to do the same thing. Defense mechanisms, can be a different defense mechanism you can generate. You can do the optimization side. So to solve this thing, first you have to take care about the optimization, model inversion, and which kind of attack will give the very sudden drift. Okay, because in the sudden drift you can easily recognize, but generally in the attacker they are the slow. That if it is very confidential, the pattern, if you find it is a little bit different, you will find it. From the observation we can easily find it, how the weights are distributed, how are weights going biased towards a certain client. You can easily find out. And for the winter internship, yeah, we are trying. In the summer internship we are providing, but currently uh, I don't have a bandwidth, so I haven't taken any summer internship. But winter we will see. If it is there, it is in the website.
Okay, thank you very much, ma'am. I think, okay, one more question is there. One more question is there.
Yeah. No, see, server never detect this thing. Maybe you are confusing about the attack detections. Okay, we need to design a model because we know that these type of attack is there. So our model should be designed such a way that it is that the if you have to design a cost function of your model in such a way so that it can be taken care about this model poisoning attack or something, because your server is not looking about the data, right? So distribution, as a server has a only one role, that whatever weight you are giving, if it I'm talking about the fed abg, whatever weights you are giving, the server role is only that it aggregates, it gives the average and it will transfer to you. Okay, it they never bothers about that whether the weight, it's just a calculate, it's just doing the computation. It never bothers about whether it is get drifted or not. Okay, so you have to think about that the local client side only, because training doesn't happen at the server side, it's only the aggregation phase. So at the client side, we need to design a model in such a way that even any attacker put a certain value. Even in such cases, it is easily, it gives the correct result. And it happens only because how we design our cost function. Okay.
Okay, thank you very much, ma'am, for giving the wonderful session on federated learning. So she introduced about the federated learning, basic concept of the federated learning, and she also explored the differentiation between the centralized and decentralized learning. So apart from that, she also tells about what the challenges are there in the federated learning. So thank you very much, ma'am, for giving a wonderful session and giving a valuable idea for all the participants, so how they can apply the federated learning in their future research and how privacy is important for the users. So very thank you very much, Dr. Vandana Bharti.
Yeah. Thank you everyone for listening. I hope I have given a few avenues where you can explore your research with your student in the BTech projects or maybe the PhD. And it's a wonderful to interact. At least I got a few questions, so I can give the answer. But it's a very good questions from your side. Thank you everyone for giving me this opportunity.
Thank you very much, ma'am. Okay, so participants, we are taking just 5 minutes break and then we can start the next session. By the time you just get refreshed, and then after 5 minutes we will come back again and start the session. Okay, and okay, ma'am. So now we are. So within 5 minutes we will come back.